So Codex or Claude Code, which one should you actually be using? Now I gave both of these the exact same 5 tasks. So explaining a real open source code base that they'd never seen before, building a complete app from scratch, refactoring a 5,000 line Python file without breaking anything, hunting down a planted bug, and reviewing a booby-trapped pull request, and I timed everything and verified all of the results. Now, the thing that I want to note here is that everybody is comparing these two tools and it's just pointing at benchmark charts. But the benchmarks genuinely cannot settle which one is better. The best independent benchmarks actually have both of these models in a dead tie. So in this video, we're going to go through the real numbers, the actual benchmark data with sources, and then the real pricing and usage limits, and also all of the demos so you can see how these perform in the real world. Now at the end, you're going to know the differences between Codex and Claude Code and which one is worth your money if you're going to be buying these subscriptions. All right, let's dive in. So before we look at the numbers, let me break down why most of the comparisons that you've seen out there are actually testing the wrong thing. Now most videos and blog posts are comparing different models. So GPT versus Claude or Fable versus Soul or whatever, you get the idea. And they declare a winner based on the models. But when you actually use these tools day to day, you're not just using a model. You're actually using what's called an agentic harness. So let me put it as simply as I can here. The model you can think of like the engine, and the harness is the car. Now the harness is the thing that decides what context the model actually sees, what tools it can use, how permissions work, how it edits files, runs tests, you get the idea. And the reason this matters so much is that a really good model sitting in a weak harness can absolutely lose to a slightly weaker model that's sitting in a better harness. So to be precise about what I'm comparing here, when I talk about Codex, I mean OpenAI's whole product. So Codex CLI, the IDE extension, the desktop application, the cloud, right? You get the idea. And on the $20 plus plan that you can purchase from OpenAI or for Codex, you get their flagship model, which is GPT 5.6 Soul. And then when I talk about Claude Code, same thing, I mean Anthropic's products, right? So what they have across VS Code, JetBrains, desktop, web, and then of course Claude Code, the CLI-based app. Now one really important note here is that the models these products provide to you are not symmetric. So on Codex, if you're using their $20 plan, you get Soul, which is their flagship model. But on Claude, if you have the $20 plan, you get by default Sonnet 5, which is their middle tier. And then if you want Opus 5 or Fable, the flagship model, that only comes with the $100 max plan or above. Now you can still use the model by paying for extra usage, but just keep that in mind if we're trying to compare them apples to apples, that you get different model availability throughout these different providers. So to keep things fair here, the demos that I'm going to do later in this video are going to be flagship versus flagship. So Soul versus Opus 5. And I'm also going to tell you every model that's running and show you some other models so you can see exactly how they perform. Just keep that in mind here because when we get to pricing, it matters which models you're actually going to have access to depending on how much you're paying. So we're going to dive into all of that, but just a quick break because I want to tell you about Boot.dev, which is one of the best learning platforms out there and my long-term partner and sponsor of this channel. Now, one of the biggest problems that I see with people learning how to code is boredom, especially in 2026. They watch tutorials, copy code, feel productive for a week, and then they quit. Now, Boot.dev takes a completely different approach. It's very hands-on and honestly feels more like a game than a course. Now, you're learning back-end development by actually building things and not just watching videos. You work through real challenges in Python, SQL, and Go, earn XP, level up, fight bosses, and progress through a full back-end curriculum. Now, it sounds gimmicky, but it actually works because you're doing the same kind of problem solving that you would do on the job. Now, they also have an AI tutor called Boots, which doesn't just dump answers on you. It asks follow-up questions and helps you reason through problems when you get stuck, which is way closer to how you actually learn. Now, all the content is free to read and watch, and if you want the interactive coding, progress tracking, and the AI assistance, that's part of the paid plan. Now, if you want to check it out, go to Boot.dev and use my code TECHWITHTIM to get 25% off your first year. Big thanks to Boot.dev for sponsoring this video. Now let's get back into it. Okay, so let me give you a quick lay of the land here when it comes to Codex versus Claude Code. Now, first thing to understand is that I'm going to be comparing the Codex CLI to Claude Code and the CLI-based tool for Claude. So I'm not using the desktop applications because I wanted to use the most kind of developer version of these different products. Now that said, both of these products have a ton of subproducts or other ways to use them as VS Code extensions or IDE extensions. You can use them from their desktop applications. And of course, depending on where you use them, you will get some different features. Now, one thing to keep in mind is that Codex is actually fully open source, licensed under Apache 2.0. You can go look at the repo, read everything, and use it however you want. Whereas Claude Code is partially open source. It has a different type of license, and it's actually not fully available to the public, even though they accidentally leaked a bunch of their source code, as you guys have looked at here. In terms of popularity, I would argue that Claude Code is much more popular than Codex. And if we just look at the GitHub stars, we can kind of see that with 142K versus 106,000. And then lastly, when we talk about the family of models here, when we look at Codex, the current models that most people are using are going to be Sol, that's their flagship model, Terra, and then Luna, which is super fast and super cheap. Then when we go over to the Claude Code side, we have Fable and Opus. These kind of sit together as the flagship models, where Fable is more capable, but definitely much slower and super expensive. We have Opus, which is kind of now their default recommendation. And then we have Sonnet 5 and Haiku, and these are much cheaper models. And keep in mind, if you just have the $20 plan, you'll get Sonnet 5 by default, not these two flagship models. There's a few other things that we could go through, but now let's go to the reported benchmarks. So here's where I have to be a little bit careful, because I promised you real data in this video, but the thing with the real data is that it's a little bit messy because it comes from both of these different companies and they're kind of marking their own homework. What I mean by that is that both of these companies publish their own benchmark charts, and shockingly, in each company's chart, they show their model as winning. So if you look at Codex, they say they're winning. If you look at Anthropic, they say they're winning, right? So let me show you what I mean by that. When OpenAI launched GPT 5.6, their benchmark chart showed that Sol was beating Claude on the specific benchmarks that they picked. So in this case, it was Terminal Bench, which measured the terminal work, and then Deep SWE. But then when Anthropic launched Opus 5, they led with completely different benchmarks. So they said, hey, SWE-Bench verified, we're better in this one. And they reported a pretty big actual difference compared to Codex. Now it's the same models, but somehow everybody's winning here. And that's because each company is picking what they want to show you. So overall, the point is, don't trust what these companies say because they're all selectively picking the numbers that make them look the best. So while we really shouldn't just trust benchmarks so they don't tell the whole story, there is one benchmark that's worth paying attention to. Now that's the Senior SWE benchmark, which was refreshed just at the end of July, so a few weeks ago from when I'm recording this video. And this has a metric called Tasteful Solve Rate. Now that doesn't just check whether the code passes various test cases, it checks whether the solution is actually good, high quality code. And on that specific metric, Fable 5, Opus 5, and GPT 5.6 are in a dead three-way tie at exactly 34.7%. Now this benchmark is only about 100 real tasks, so it doesn't mean anything drastic, but the point is that in some independent benchmark, right, like this one right here, all of these models performed almost exactly the same. So don't trust what these companies are saying and understand that all of these models have different advantages and disadvantages, which we'll get into in a second. Just to further prove my point here on why you shouldn't just blanketly trust benchmarks, look at a few of the stats that I have on screen. I'm not going to go through all of them. Basically, some of the benchmarks themselves don't actually rely on how well the model performs. It relies on the compute, the configuration, how the task is actually set up. And these companies themselves have actually found that some of these benchmarks can be pretty unreliable. So we're pretty much at a point now where the flagship models are so good that things that actually dictate how well they perform are going to be more related to what machine you're running them on, what environment you have in them, what setup instructions you give them, and specifically the exact task that you want to run. Anyways, let's have a look at the cost now, which I think is probably the most compelling reason to pick one over the other. So we're going to look at the API pricing here because this is really the only way to compare them, but keep in mind you're going to get a lot more usage under the subscriptions. Now on the API side, the flagships are basically neck and neck in terms of pricing. So if we look at GPT 5.6 Sol, that's $5 per million input tokens and $30 per million output. And then if we look at the Claude side, Opus 5 is $5 in and $25 out. So Claude's actually slightly cheaper for Opus 5 specifically, but then if we go up to Fable 5, for example, we have $10 in and $50 out. But the standout numbers on this chart actually come when we look at the cheaper models. So if we look at OpenAI's Luna, that's just 20 cents in and $1.20 out. And there's nothing in the Anthropic lineup that's anywhere near that price point. So if you're doing high volume stuff that's relatively cheap, that doesn't require a lot of intelligence, that's a massive difference. Okay. Now let's talk about subscriptions because realistically, this is where all of you are probably going to be using these models from. So the entry prices here are pretty much exactly the same. However, what you get for them is not. So if we look at Codex, they have a free tier. They have an $8 Go plan, which is honestly one of the cheapest way to use these tools. They have a $20 Plus plan, and then they have a Pro plan that starts at $100. Then if we look at Claude, they have a free tier as well. They have a Pro tier at $20 a month, or $17 if you're paying annually. And then they have a Max for $100, which is 5x the usage, or $200, which gives you 20x the usage. And here's the asymmetry that most people don't really talk about. On Codex, the $20 plan includes Sol, which is their flagship model. But on Claude, the $20 plan gives you Sonnet 5, which is kind of their middle tier. And if you want Opus, the flagship model, that starts at a $100 max plan, okay? So dollar for dollar, OpenAI is handing you a lot more model and honestly just more value at the entry price. So all of that's great, but here's the part that the pricing pages don't really tell you, which is how far the money actually gets you in terms of usage. Now, at the time of filming this, Codex is clearly much more generous compared to Claude Code. So let me give you some actual numbers. It's hard to verify all of these, but this is kind of the best I could come up with. Now on the Codex side, community trackers put the $20 Plus plan somewhere between 10 and 100 Sol messages per 5-hour window. And you get way more obviously if you're going up to the cheaper models, so up to 2,000 messages on Luna. And on top of that, in July, OpenAI actually temporarily removed the 5-hour cap on paid plans entirely, so right now there's effectively just a weekly limit. Now on the Claude side, the best community estimate is around 45 prompts per 5 hours using their Pro subscription. And I have to say that's an estimate because Anthropic doesn't actually publish any of these numbers, and your Claude Code usage is all coming out of the same pool as your regular Claude apps. So if you have a long chat conversation just using the Claude website or the desktop app, that's also eating up your coding quota. And there's also a weekly cap sitting on top of the 5-hour window one. And what I'm going to do is just share my experience here because it's kind of difficult to know exactly how much usage you're actually going to get. Now, from my experience here, when I compare my usage with Codex and Claude Code, very similar tasks seem significantly cheaper in terms of the amount of usage that they use when I'm with Codex. I would put it at an estimate of probably 3 or 4 times cheaper in terms of the amount of usage that's used up. Now, to be fair here, Claude and Anthropic has been increasing the 5-hour window or the usage limits in that time, and both of these companies are constantly changing the math and the formulas and all of their usage and adding credits and all of this crap, so it's very difficult to track, but generally speaking, if I had to pick one that's giving you more value, Codex is a clear winner. Let me know what you guys think about that in the comments below. Okay, so very last thing, and then I want to get into real demos so we can see how these models perform on real world tasks. Now, both of these companies have kind of converged their products to have pretty much the exact same features. So if we look at Codex and we look at Claude Code, maybe a year ago, they had tons of different features, and there were some things you could do in Claude you couldn't do in Codex, and vice versa. But at this point, they pretty much all have the same stuff with very minor differences. So skills, hooks, project rules, subagents, MCPs, and there's no real reason to pick one over the other purely from the feature set. Generally speaking, what you're picking here is the harness and the model. You're not picking any of the individual features. And really what you're looking for is probably the best value and also just how well these models complete various tasks. So with that said, I have a bunch of demos here. Let's get into them and see how these models actually performed. Okay, so the first task that I had was to explain a code base that these models have never seen before. You can read the exact prompt that I gave them, and I ran this through Codex CLI as well as through the Claude Code CLI tool. Now I'll just quickly open it up so you can see what it looks like. This folder here, Analyze Codebase, is what the codebase looks like. You can see we have all the stuff directly from the GitHubs. We have a bunch of Python files. We can look at it here, textual, all of this stuff. That's the module that we were looking at. We have various examples. We have references. We have questions, notes, images, right? This is just a real repo. We have tests like disabling and testing animations, and you get the idea. And what I did is I put this inside of both a Codex folder and a Claude Code folder, and I just had them run through and give us the analysis. Now, in terms of the analysis, you can just see some examples of the results that we got here, just showing you I did actually run the task. And let me give you the overall results across a bunch of the different models from these families. Okay, so here are the results. You can see all of the timings for these various models as well as how many lines they actually produced. Now, I looked at all of these and they all gave me a decent analysis of the code base. Of course, the stronger models gave me a better analysis, but the one thing to keep in mind here is that Opus 5 took over 5 times the amount of time than Sol. Now, that's because it wrote me 635 lines, which is literally like an entire book of analysis of this code base. It did a lot more. It actually verified everything. It went through, it wrote tests, it wrote scripts, and it just outputted much more than these other models. But that's not necessarily what I wanted it to do. I gave the exact same prompt to all of them, and what I'm noticing already, and you're going to see with the rest of the demos, is that Anthropic seems to take a little bit more initiative. It writes more code, it does more things in general, even if you didn't explicitly ask it to do so, whereas Codex is a little bit more to the point and just gives you directly what you were asking it to do. So anyways, you can see the results, you can see Terra, Haiku, Luna, you get the idea, and now I want to go into the next demo. Okay, so for the next task, I wanted these models to build something from scratch. So rather than looking at existing code, just build something without any prior reference. So what I did is ask them to build a complete habit tracker in the empty folder that I gave them. I wanted to use fast API, SQLite, HTML, JSS, CS, you get the idea. And then I gave it a few requirements in terms of how to count streaks and all of this kind of stuff. Now, these are the results here. I'm going to show you what we actually got, at least from the flagship models. But you can see, generally speaking, again, with Codex, we got the result faster. However, it wrote less in terms of verification and making sure that everything worked. So I wanted these to test their own code and make sure that everything was working properly. And if you look at Opus, for example, we had 27 tests that it generated. Whereas with these other models, it really went kind of a little bit more bare bones. And again, with Anthropic, it just overall did more. So regardless, let me show you what the finished code actually looks like in terms of what we got, then we'll go to the next demo. Okay, so this is the habit tracker that was built with Codex. Let's say I want to practice running or something, I can add the habit, and then it has these streaks that we can kind of check off to say if we've done the task or not. It's very straightforward, but if we actually looked at the code, we'd see we have APIs, we have tests, we have all of that kind of stuff. Now let's have a look at the one that we got from Anthropic. Okay, so this is the habit tracker that was made with Opus 5. Let's say I want to learn my Indonesian. I can add this as a habit. We can see we have a streak. We can mark it as done, and then we can indicate. So if we look at the Codex one, initially it gave us a lot better styling actually, but this obviously still works as a basic habit tracker. Now I know this is just a simple task. The point is to kind of show you the difference in output that we get and what actually happened. And again, if we analyze the code in this one, it wrote significantly more tests to verify that the streak logic I asked for was working properly, rather than focusing on kind of the styling of the site. So now we move on to the next demo where I wanted to split up an extremely large file using these models to see how they could kind of refactor this and make sure that they didn't break anything. So you can see I asked to split a 5,040 lines without breaking anything, and then I gave all of the information. It's the same thing, this textual file. So in that textual, module, there is a file with over 5,000 lines. So what I did is just pass those to the models and ask them to split it apart and make sure they didn't break anything and that it kept working. All right, so let's get to the results. You can see that 6 out of the 7 models here successfully completed this task. Haiku did not. While it did actually write the separated code, it didn't remove the original file, so it did not complete the refactor. And you'll notice the OpenAI models took significantly less time to run compared to the Anthropic or, Claude models. Now you'll notice even with Opus 5 here, this took 36 minutes. That's almost 5 times longer than Sol, which actually, funny enough, happened to be the fastest model to run here to get the exact same thing. The difference was that with Opus 5, this actually wrote a complete proof tool to verify that everything it did didn't break the original file, so it did significantly more work than we actually asked it to do. Now, same thing with Fable and with Sonnet 5. If we had a look at their code, you'll see that it looks more complete, it's more documented. However, it took so much longer and it's doing more than actually is required to complete the task. Because again, I use the exact same prompt for all of these, and this is the result that we're getting, which is kind of proving to me how these models behave when given something that's not super specific. All right, so I've got 2 last demos to go. Just wanted to add a little bit of diversity here. The point of this demo was to try to see whether or not the weaker models would fail at a more complex or kind of vague bug report. So what I did is just had like kind of a demo, pseudo issue that a user might report for an application. And what I did is pass these to the models and see if in this small code base they could fix the bug. Now, if we look here, all of these models were actually able to find the solution and to fix it. One thing to note is that Sol here gave us the smallest, most concise fix, which was just 2 lines of code. Again, notice that the Anthropic models took significantly longer, right? In this case, we're almost 3 times longer than Sol if we're looking at something like Sonnet 5 or Opus 5 to do the exact same thing. So even these weaker models, which is what I was kind of looking at here, were able to find this, which was kind of a surprise for me, and goes to show that a lot of times you don't actually need the highest level of intelligence, especially for, more simple kind of coding tasks. Now let's move to the last demo here, which was to review a pull request that I actually injected a few bugs inside of. So I did 3 bugs intentionally in this pull request. I wanted the AI models to review this just like they would if you were actually submitting a real pull request, and to figure out what the problem was and give me all of them. Okay, so what happened here? Well, all of the models found the 3 bugs that I planted, and actually I even found a 4th bug that I didn't mean to introduce into the pull request. Now again, you'll notice with the Anthropic model that it actually took longer, kind of the trend we've been seeing here, but did more. So it wrote kind of a more complete, let's say, solution to the problem. Even though all of the other ones were correct, this went, a step above and beyond to write more code to make this just even more kind of bulletproof in the future. Now, these last 2 demos here were meant to just be smaller ones, and the reason I ran them was to see how these kind of less efficient or, less smart models would actually perform. Now, on these small, well-scoped tasks like finding bugs, reviewing code, whatever, every tier of these models is operating at a level that would pass for a solid software engineer. And really, the differences that we're seeing here are speed and the depth of explanation, but not the correctness. So that's kind of the real separation between these 2 products and model families here. It's not can they do the task, it's how deep do they go and how kind of in-depth is the explanation. Sometimes that's good, sometimes that's bad. And now I want to talk about how do you actually pick which one you should be using. So overall, my recommendation here is to choose Codex if you want the fastest and most efficient tool. That's because it performed the exact same task with the same correctness level, much faster, sometimes 4, 5, 6, 7 times faster than the same comparable Anthropic model. Not to mention the fact it has much more generous usage limits, and you can access the flagship model for just $20 per month. Then you should choose Claude Code if depth is really what you care about. Now that's because in my testing, Opus went further on every single demo that we did. The analysis was 600 lines of code, for example, right? The build had more than 3 times the number of tests, and in the refactor, it actually built its own verification tool and caught regressions that no test suite would have found. So you're paying for that depth in terms of time and the quota, and that's ultimately the trade-off here, right? Because remember that to even access these higher end models, at least through your subscription, you need to pay at least $100 per month. And honestly, the real answer for a lot of you watching this is that if you can afford both of these subscriptions, you should probably just have them both. They have different failure modes, so the tool that writes one change is not always going to be the one that spots a problem with it, and $40 a month is relatively cheap for kind of a second option on your code. Now, the days of this being, this religious warfare on Codex versus Anthropic are pretty much over. They're both very similar, but again, when you can use them together, I think you just get the most benefit. Now, what I would not do is just pick one of these because of one of the results you saw or one, random benchmark online. Ultimately, it comes down to what you are doing because both of these are going to perform differently depending on the type of task that you give them. Again, what we've kind of generally seen here is that Codex is going to be more efficient and faster, whereas Claude is a little bit more in depth. It's going to do more for you, take a little bit more initiative. Sometimes you want that, sometimes you don't, which is why my recommendation is pretty much just take both. All right. That's what I had for you guys. I hope you found this helpful. Let me know, do you agree with me? Do you disagree with me? What have you found in your testing? Leave it down below, and I will see you guys in another video.